So today I'm answering some questions on how we run lights out production, our method for finding the best solution, and how using lean principles improved our financial metrics. Let's get started. We'll just take 2 or 3 minutes here, peek into the windows and just watch the machines for a little bit. These two have bar feeders. So again, sawing individual pieces was over processing. Now we take a 12-foot bar and we saw it into 4-foot sections, 2, 3 cuts. We load it into the bar feeder and then it feeds the machine. These are 2 out of the 3 machines that run lights out unattended. Yeah, I've said publicly, it's the easiest way to print money without going to federal prison. Super easy. You just feed it and let it run. So, yeah, very simple 2-axis lathe, my first one, up to my most recent purchase, 9-axis turn mill.
So I know you said profitability and saving time isn't like your main focus,
Yeah,
but
no.
Have you guys compared like how much more efficient you are now versus companies who aren't implementing lean, or even compared to how you guys weren't?
Yeah. So what we do is we do what's called job costing. So we'll take one of the responsibilities of my director of finance is to always have his finger on the pulse of material. Like when we reorder material, how much did we buy? What was the cost? And what's the total yield on the 10 bars of 12-foot material? How many parts did we get? Then he looks at cycle time and then the shop rate of the machine. So we actually charge a lot. We want to, if we're a top shop, we should not be giving rock bottom prices. So a really poorly run shop, inefficient, should probably be in the $40 to $60 range of the hourly rate. We're gonna want to run this machine in the hundreds. Like this one runs at around $250 an hour. But because we are efficient, we know that component, we could go head to head to a shop that runs this machine at $100 an hour and it's throwing a ton of labor at it, ton of setup charges. We get that $250 an hour rate because of our efficiency. So that's why we don't need lots of machinists. That's why we do invest in cutting edge technology. And so we get to charge for that. So, as we should. So, yeah, and so we've got a spreadsheet. We go, wow, okay, we're actually seeing that profit margin shrink. What do we need to do? Do we need to A, make it more efficiently? B, do we need to renegotiate prices with our material supplier? C, do we need to add better equipment? And so we want to create that buffer should float like this. When material prices go up, we don't want to just immediately pass it on to the customer. That stinks for the customer. We want to see how can we make it more efficient? And it kind of brings like a red light. Hey, we're crushing some profit here. Oh my gosh, we were doing 5 tool changes. Now we can do two of them just by reprogramming. That's great. So
and that's where also that like culture of like constant improvement.
That's right.
Comes into play too.
Continual improvement. That's a huge one. Yeah. Mm-hmm. Yeah. So Max was just talking about inspection. Obviously, we don't want bad parts going out. So our thing is the best blank is no blank. So that speaks to simplicity. So the best inspection is no inspection. If it doesn't need to be inspected, if it's not super critical, we'll do an initial first article inspection. But if it drifts and we design our parts so that if it drifts 5 to 10 thousandths and it's just cosmetic, oh well. The critical things, that's when we want to deploy brain power. Like one of the 8 ways is misuse brain power. We don't want to misuse brain power by inspecting a cosmetic part, but we want to properly apply brain power to the things that are critical, fitments, performance-based, those types of things. So yeah, Max was just saying, you'll notice on some of the prints, some things are highlighted, some things are bubbled, which specifies you need to do 100% inspection every part that comes off, 100% inspection, or redundant, like the assembly guys will, yeah, it got inspected by a guy here, but it's too critical of a component to not inspect a second time. So we'll bring out our inspection tools. Again, we love our CMM, our coordinate measurement machine, which is a digital CNC version that touches with a probe and gives you detailed reports. It's great, but it's slow. It requires programming, it requires knowledge, And unfortunately, it's in the corner, and we have to build a climate controlled room around it as well to keep it at what, 68? Yeah, 68 degrees Fahrenheit or whatever, 30 Fahrenheit or Celsius. Yeah, but if it's not necessary, we don't want to do it. So again, just prioritizing simplicity by not compromising also on defects. So if you're interested in learning more about our journey from a small shop to a lean factory, make sure to hit that like and subscribe button for more tips and tricks. Now, go innovate your production.